Greetings on the day. I am Sridhar, Assistant Professor, Department of Electrical and Electronics Engineering, Manipali Institute of Technology and Science, Manipali. Last class we discussed about series circuits. So this class we are going to discuss about parallel circuit with the practical as well as theoretical explanations. So before go to this, we had to know about the Ohm's law statement. Ohm's law, the statement is the physical conditions of the conductor remaining constant, the voltage across the terminals of a conductor, which is proportional to the current flowing through on it. So we had to know about the formula related to V and I and R. So V equal to IR and I equal to V by R and R equal to V by I. And come to this parallel network, um, when one end of each resistor is joined to a common point and the other end of each resistance is joined to another common point, so that there are many as path for current flow as the number of resistance, so which it is called as a parallel circuit. So here a diagram is shown for parallel circuit. So look about this diagram. So here three resistors are connected in parallel and one voltage source is there. So in this parallel circuit, these conditions are very important. That is the sum of the current. So if you see that the current which it is goes in each and every path, like I1 current, I2 current and I3 current. So in this way, so the sum of the current I1, I2, I3, which is equal to that the total circuit current. So we can say that I is equal to I1 plus I2 plus I3. Likely applied voltage V, which is across to each resistance in the same. So we can say here that V, that applied voltage V, which is equal to V1 equal to V2 equal to V3. Okay. So from Ohm's law, we know that voltage is equal to current into resistance. V is equal to I into R. So in that we can find I, that means I equal to V by R equivalent. So here different currents are there in this parallel network. So I1 is equal to V by R1, I2 equal to V by R, V2 V by R2 and I3 equal to V by R3. For a reference, we can make V1, V2, V3 also in that depending upon that the potential resistance between that. So if you solve that, we can get a R equivalent for this parallel network. So 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in this case, we can conclude that if n number of resistance which are connected in parallel, then the equivalent resistance will be. So we can write that R equivalent that is equal to R by N. So in that the form, see here one network is given here. So in this case, so if you go and check this, here two resistance are connected in parallel. So here we can write an R equivalent like 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So in this case, R equivalent if you want to write, so due to that product and sum, so you'll be getting that R1 R2 by R1 plus R2. So if you want to solve some problem also, see here R1 is 8 ohm and R2 is 4 ohm is given. So if you consider R1 and R2, so if you want to write R equivalent among on this particular network, so 8 into 4 by 8 plus 4, you'll be getting that 8 by 3 ohm. So likely, if you come here, how we seen in a series resistance, I mean in a series circuit, we seen that voltage division rule. Likely here we are going to discuss about the current division rule. So consider this network. Consider this network. So in this network, if you want to write that R equivalent, we have two resistor, namely as R1 and R2, and two current path will be there I1, I2. So R equivalent, which is equal to R1 plus R1 R2 by R1 plus R2. So from here, that voltage, if you want to write V equal to I into R from Ohm's law, and I equal to V by R. So if you want to find only I1 current, so we can write I1 is equal to V by R1. So from this we can find that current value what it is. So the formula we can rewrite this from this equation. See I1 is equal to I into R2 by R1 plus R2. The same case if you consider in this second path of current which it is I2 which it is notated here. like R2 resistance. So I2, which is equal to the total current I into I R1 by R1 plus R2. So this is current division rule has to know to find individual current in that the parallel circuit. So in that the same case, while we are going to check about the practical point of view. So in this, we have two lamps which are connected in parallel. The phase and line which it is taken from the source, like single phase 230 volt 50 hertz AC supply. So here one SPST switch is there, that is single pole single throw switch. So here it is individually connected. You can check about that neutral part as well as the line part, that is individually connected for each and every holder for the lamp 1 as well as lamp 2. In case if lamp 1 it may be damaged, so lamp 2 will be work. Or example, if lamp 2 will be damaged, even lamp 1 will work, depending upon that individual uh, connection in parallel circuits related. Okay, and we will do see one problem. So here one network is given, two resistors are connected in parallel, applied on voltage source 12 volt. So here two resistor of resistance having 3 ohm and 6 ohm, which are connected in parallel across a battery, having a voltage of 12 volt. So here has to determine that the total circuit resistance and the current flowing in 3 ohm resistor. So here total circuit resistances are equivalent we want to find in this parallel circuit, as well as the current flowing in 3 ohm resistor. We have 3 ohm resistor here, that is R1. We can consider R1 and R2. So in this case, R equivalent we can write as a parallel network, that is R1 R2 by R1 plus R2. We know the value. If you substitute that the value directly, you can get that the total circuit resistance what it is. That means 6 into 3 divided by 6 plus 3, you will be getting 2 ohm. And come to second one, the current flowing in 3 ohm resistor. So current flowing in 3 ohm resistor. So you want to find the current. We can go again that Ohm's law, like I equal to V by R. So I1 you want to find, because here two current are there. I1, I2, two current are there. So I1 is equal to V by R1. Why? Because R1. So R1 3 ohm resistor we has to find. So I1 is equal to V by R1. V value is given in that the question, that is 12 volt. So 12 divided by 3. So simplify, you'll be getting 4 ampere. Likely you can find I2 also. So I2 equal to V by R2. So if you simplify, you'll be getting I2 current. So here parallel circuit current I equal to I1 plus I2 plus I3. That's a form, right? So here you can go by this current division rule also. Previously we seen. So if you want to go to see about the current division rule, before that we had to know current value I equal to V by R equivalent. So V is given in question itself, 12 volt divided by R equivalent is 2. So after simplifying that, you'll be getting current value 6 ampere. So if you find I1 path only, I1 current in that the given circuit, so I1 is equal to I into R2 divided by R1 plus R2. That formula, if you apply here, that is I1 is equal to R into 6 divided by 3 plus 6. So you'll be getting 9. Simplify that, you'll be getting 4 ampere. So from this we can conclude that how parallel circuit can solve. Okay. So if you have any queries and any discussions, we can follow in this link. We will see in next session. Thank you.